is my first talk here. So a bit of introduction about myself. So I'm working with OpsTree as a senior DevOps specialist, and I've also recently become a CNCF Cubestronaut, and with 5 years of experience with in the DevOps engineer vertical. So I'll be walking you all through the how CI has evolved over the years, and why it has become so important that we have a CI system which is resilient to all of the production issues that occur, and how deployment velocity and all of these metrics have come into picture, and how engineering teams are leveraging these metrics to actually make their pipelines more and more faster and battle ready. So the question starts with how much do software bugs usually cost? And according to a survey done by Gartner, so it costs around $5,600 per minute for a downtime in production. So if you extrapolate that to an hour, that will wipe out an engineering budget of a small scale company, probably an annual budget of a small scale company. So the earlier that you identify the bug in the development life cycle, the cheaper it is for you to fix it. So let's say you identify a bug in development phase, it might cost you maybe $10 or $15 to actually fix it. But as you go later and later in the software life cycle, it will end up costing you $10,000 or $20,000 to fix that small bug. So we don't want unwarranted downtime, and this is where the CI, this was the whole idea for CI to come into picture. So this is not something very new. CI has been in existence since 1997, and it was actually coined by Kent Beck and Ron Jeffries. It was part of the extreme programming practices, and their idea was quite simple. It was integrate everything and integrate as fast as possible and automate everything. So the whole idea was have as small feedback loops as possible so that you can fix issues quickly. So that started off the idea of CI, and even 28 years later now, it is even more relevant to companies across the globe that they have very good CI pipelines. So what actually is a CI? So it's the practice of automating the integration of code changes from maybe multiple developers and compiling it into a single software project. So now that we have understood what CI actually is, so we'll look at a bit deeper into what are the different checks that CI does, and how the CI lifecycle should ideally look like. So CI typically consists of two phases. You can have pre-built checks, which has basic testing even before you compile your source code. So let's say you're doing a dependency check, or you're doing Git leaks scanning. All of these checks can be part of your pre-built checks. They are typically quite fast, and their execution time hardly lasts for a minute or so. Then you can have the post-build checks, which are a bit more extensive. They take a lot more time, maybe functional testing, integration testing, or dynamic application security testing. All these checks can be part of the post-build checks. And once you have a ready-built artifact, then you can send it to the CD system where it will handle the release management. So now comes the question how do we know when to trigger the CI pipelines? So we have two schools of thoughts over here. One is the pull-based mechanism, and the other is the push-based mechanism. So the pull-based mechanism is basically the CI keeps checking with the version control system if any changes has happened to the repository, and let's say it finds out any changes has happened, then it is going to poll those changes, and then it is going to run the entire CI cycle, and it is going to publish the artifact. The problem with this is that there are too many calls that are going to the version control system, and it does occupy some amount of compute as well. So now we fairly recently we have started off with push based mechanism where we write webhook events where the developer pushes code into the version control system, and on the basis of that push, once that event gets triggered, the VCS informs the CI system that a change has happened, and the CI system then runs the pipeline and it publishes the artifact. So this reduces the problem of too many calls being made to the VCS system. So this is about the different triggers which are present. Um, yeah. So let's look at the pre-built checks a bit more in detail. So before the code compilation, so you can have credential scanning. Let's say you have any passwords that you have written out in your code. So you don't need to actually run your source code to actually check all these things. Credential scanning can be done. Then we have dependency scanning, where let's say you have a Node.js application and you're using some external libraries. So all the dependencies can be checked for any security vulnerabilities that are there. You can also use license analysis tools, where let's say you're using any third-party tools which involve licensing. So you can check if the license is valid or not. Then you can do static analysis scans and code coverage checks, where you are checking like how much part of your automated tests is actually, how much part of your code is being covered by the automated tests. So once we are done with the pre-built checks, the pre-built checks are, as we have discussed earlier, they are quite quick. They are supposed to be quick. And then we have the post-build checks, which are a bit more extensive. So once the application is up and running, you can do the health check validations. Maybe you can configure an API endpoint, which you can keep polling and check if it is up and running. Then you can do sanity tests and functional testing and integration testing, which are a bit more extensive. And then you can finally move on to the dynamic application security testing, where we can poll the HTTP API endpoints and check for any security vulnerabilities that are there. So these post-build checks are usually a bit more extensive, and you can configure them in something called as nightly CIs, where irrespective of like the schedule that you have for the CI pipelines, you can run it once every fortnight or once every couple of days to do these kind of checks. So CI doesn't just end with that. So what if the developer wants to understand like where the actual issue is, or if his CI pipeline has finished execution or not? So that's where the notification system comes into picture. So the developer doesn't want to sit in front of his laptop and wait for the entire pipeline to get executed and then understand if it has run or not. He can actually leverage all these types of notification systems, like let's say Slack or mail channel or Teams, to figure out like if if the pipeline that he had triggered has run successfully or not. So typically here also we have two systems. We have the sync communication, which is used for real-time alerting, and we have the async communication, which we use for a bit more detailed analysis, like let's say the code coverage reports and all. We can publish it via the async channels. Then a quick side note, so we have this segregation like what is data and what is information, right? So we all know that data is unprocessed and it is hard to understand, it is difficult to interpret. You need to do a bit of processing and make it into something knowledgeable or something which you can easily understand. So in the notification system, this plays a very important role, where if you can see, it's a screen grab of a Slack notification, where it just says that your build number is so and so and it has run successfully. But at the same time, if you look at this is a bit more extensive. You will have all the links to the different reports that have run or the different scans that have run. This is a bit of the data part. Then comes into picture the artifact server. So once the CI pipeline runs and it generates a build artifact, so that needs to be hosted somewhere, and that's where the artifact server comes into picture. So it is the single source of truth for the applications. And as of today, we have multiple artifact servers, like we have Nexus, ECR, and we have Artifactory by JFrog. And this here again, you can see Harbor Artifactory repository. So typically, it'll be a Docker image or a image that you're going to build, that you're going to host it here. Then comes into picture the reporting server, where you can see visually all the like key metrics. Let's say you want to look at a maturity overview, like how is the code quality across all the builds that are present in my system, and what are the different like security reports that have been generated. I can look at them visually and I can analyze and figure out where I need to improve. We can also have a velocity insights, where we can understand like across builds how much average time is it taking, how many of the builds have passed successfully and how many of them have failed, and if a failure has happened, like what was the primary reason for the builds to have failed. So these become a very important aspect of the CI lifecycle, because you have to understand that once the CI pipeline has run, like is it going to successfully deploy my application or not? So this is a holistic view where the developer actually pushes some code, the version control system sends the trigger to the continuous integration cycle. We have a few pre-built checks, unit testing, code coverage, and then we have a few post-build checks which run, which are integration tests and security testing. We get a deployed artifact and it goes to the artifact server. We get reports which are generated from the different checks that are happening, which goes to the reporting server. And then we have a notification channel where the developer gets notified if his build has run successfully or not. So now comes the question that how extensive should I go with my CI pipelines? So you can have a very minimalistic pipeline where you just pull the code, run a basic credential scanner, build the artifact and publish it. This is basically analogous to, you can say that I have a CI pipeline. But then this is not how actual things work in production, especially for world-class organizations. So typically that picture, this is a more extensive workflow where you can be sure that once I run the build, I'm sure that my application is going to get deployed into the production, and I needn't worry about something failing in between. And even if something fails in between, I am going to be aware of what the failure is. So here we have the version control pulling the code, then we have pre-built checks, SAST and quality analysis. We have a built artifact, then the deployment happens, then we have a few post-build checks that are run, and then we publish it. So again, so we have a few generic CI checks which we can make a template out of it. We don't need any application as such for these checks. We can do credential scanning, and that can be done irrespective of what application that you're doing the CI pipeline for. We have credential scanning, commit message validation, Docker file linting, container image scanning. So all of these are like something which are bare minimum that you can have in a CI pipeline. Then you have like language specific or application specific CI checks. For Java, you can have their like Aquasec Trivy, then you have a pivotal license finder, spot bugs, then you can have PMD Apex and check style. So all of these are Java specific tools. So you can build a job template where you have a Java specific pipeline in place. So whenever you are creating a new microservice or a Java based microservice, you can directly import this job template, which is going to give you pre-built. Then we have again Python specific checks where you are using PyTest, PySA, all these tools to do the Python specific scans. Again, Golang specific checks and PHP specific checks. So now the question arises is application code the only candidate for CI pipelines? And I mean, if anybody can, answer this.
No, you can like use any endpoint service, MCP service,
Yes.
MPP services, voice security, everything can be a pipeline.
Yes. So anything which can be codified basically can be a pipeline candidate. So infrastructure as code, Terraform code that we write, that can also be a CI pipeline candidate. VM infrastructure code, we use Ansible for that, for configuration management as well. So that can also be a pipeline candidate. Your Kubernetes YAML files can also be a pipeline candidate. Your Docker files can be a pipeline candidate. Your Helm charts can be a pipeline candidate. So anything basically which can be codified can be a pipeline candidate. So again, here you have a few Terraform, like a sample Terraform pipeline that you can have, where you use tflint, Terraform validate, or checkoff, and then infra cost. You can use all these tools to actually do Terraform specific checks. Then this is the Ansible specific checks that you can have. So we can use Ansible CMDB or Molecule for doing unit testing and all these tools. So we have a lot of orchestrators present in the market as of today. So we have Jenkins, GitLab. I'm sure you must all be aware of Jenkins because that's one of the most commonly used orchestrator. We have GitLab, then we have Harness, we have Circle CI, we have Azure DevOps. And with OpsTree, we have our own built-in in-house solution, which is called Build Piper. It's a whole DevSecOps platform in itself, and it also has like AI-powered agents where you can ask it questions like, hey, what development, give me a few development insights, or give me how many builds have failed, or what was the primary cause for the build to fail. So now the question arises, like, what should a perfect CI candidate look like? So with Build Piper, we have something called as a step catalog, where we have predefined steps where you can directly leverage these steps. Typically, if you ask anyone to write a pipeline, they write a YAML file, right? So instead of that, we have a simple drag and drop option. We have generic steps. We can just leverage those steps. We can configure whatever changes need to be done in those steps, and we have a ready built pipeline.
Do we also have import of YAML? Like usually you are doing the CI for application, right? If I want
Yes.
to import data, I will have a customized YAML usually.
Correct.
Does the
Yeah, so if you can see this view, you have a canvas view and you also have a YAML view where you can get the entire YAML for the same pipeline. So here you can do a simple drag and drop, and let's say you can create generic templates. We also provide generic templates which you can use and leverage that. So if you don't want to run certain steps, or if you have your custom steps as well, we have that feasibility as well, where you can give your custom steps. It's a simple bash script that you have, because that is something everybody is aware of. So we have made sure that those custom steps are written in bash, for which we also provide a boilerplate. Then this is a sample execution of a pipeline. You have logs, like let's say this is an OWASP scan report. So you can clearly see like what all packages are there and what version we are using, and in what version that particular vulnerability has been fixed. Similarly, this is a Terraform pipeline. This is a screen grab of a infrastructure cost overview. So once the Terraform creates all those resources, the resources that have been created, how much is it going to cost us? So this here is what the AI agent that I was referring to. So you can ask it questions related to all your applications, like all the builds that are there that are happening, and maybe you can get deployment insights for a particular time period, let's say for the last 1 year or for the last quarter. So you can see how many builds have been successful and how many have failed, and what was the primary reason for the failure. All these things you can directly ask it.
And do we have control over the prompt which we are like sending for the AI, or like?
Yes, it's similar to what you do with ChatGPT. So yeah, so that's about it. Like I think deployment velocity has become a very key metric for most of the big organizations where the developer, once he writes a code, he wants it to get deployed to production as quickly as possible, and that's where the CI pipelines and the faster execution of and parallel execution of CI pipelines helps out. So I'll walk you through a brief demo of the build piper as well to showcase like what capabilities it has. Just give me a second. So what makes build piper like more robust when compared to the other CI orchestrators which are there in the market? So this is basically DevSecOps as a platform, and it is application centric. So the whole focus is anything and everything related to the application should be available for us in a single view so that we can avoid tooling chaos. So let's say you are in having an application. To monitor that application, you use, let's say, Grafana or Prometheus. So all of these are different tools that you're using and that you're leveraging, which are external. Again, you don't have a single view for that. So, but with Build Piper, what additional features that you see is, let's say you have a Kubernetes cluster on which you're hosting your application. That Kubernetes cluster you can directly onboard here. Let's say I'll just show you an example. So if you can see, you can also see the how many worker nodes are there in that cluster, what are the current resource utilization of those nodes, and like what all resources are present. Let's say you have ingress resources configured over there. You can see the public ingress protected if they are private or protected. Then you can also have the infrastructure monitoring tools configured directly, Grafana, Prometheus, Alert Manager, all of them. You can also see like what all pods are available within the cluster, how many nodes we have, like do we have any taints, tolerations, annotations. All of these are directly available via the Build Piper UI itself. So we have two different views over here. This is the admin portal that we have, and we also have the user portal where it is again application specific, where you are actually creating the pipelines. The user portal is more from the the administrator portal is more for the admin purposes, where you onboard Kubernetes clusters, where you manage user policies. We also have like role-based access control policies present, where you can restrict users, where you can restrict users like from certain set of features. So I'll just walk you through the user portal as well.
And this can be locally hosted.
Yes, you can locally host it. Like it's as of it's a paid tool. It's not open source as of today, but you can try it out definitely. Yeah. So if you see, you can get an overall picture. You have 70 different applications, 281 microservices which are there, and 11 clusters in all, and 113 pipelines. So you can pick any application. You can just check what all pipelines are configured, how many environments are configured. Like I can have dev, quality, production. I can also add like custom environments that I have over here. And the templates that I was referring to earlier. So we provide custom templates built in to the platform. So you can leverage these templates, or you can edit these templates and put in your custom steps as well. So we also have the velocity insights that we were looking at earlier. How much average time was my builds taking, how many of them were in a success state, how many of them have failed, and similarly you can have for the deployment summary as well. So yeah, that's about it. If you have any questions, please feel free to ask.
So this is for now it's a closed source, right?
Yes. If anybody wants to, check out more details regarding Build Piper, you can scan the QR and you can explore it a bit more.
Regarding the drag and drop feature,
Yes, yes. So I've showed you the canvas and the YAML view, right? In the canvas view, whatever you do a drag and drop, it can be seen in the YAML view as well. It will get updated immediately.
We'll take one more question.
Yeah, sure.
So as we know, like we have multiple tools like GitHub Action